All right, GM everyone. What are we gonna do today? Today is day 5 of 15 smart contracts in 15 days, and we are going to understand something which is called token vesting. Now, since we are hitting the 1/3 mark of the series, let's get into some complex and advanced stuff. So we built the ERC20 tokens yesterday. Now, what are we going to do is we will establish some control and some authorization over this. The rates of it will not be affected by it any means, but the release and supply of it can be monitored and can be changed as per our requirements. So here is a diagram that shows what is token vesting. So mechanism where cryptocurrency or tokens are allocated to individuals or entities, but are released gradually over time, not all at once. So as we just saw yesterday over this MetaMask wallet, let me show you. Whenever I sent the MTK to a person, what happened was the transaction was just in an instant. The tokens were deleted or reduced from here, and tokens were added or sent to this address, right? This is called instant sending. Now there is something called vesting. So in vesting, what happens? Imagine I have this company. So let's say this is my company and I am the founder of it. So boom. This is the founder, and let's denote it by F in the chat, and then we have, let's say, 2 and 3 investors. Okay, here we have 3 investors. Let's say 1, 2, and 3. Let's name them A, B, and C. They got a little merged up. Let's separate them. Let's carry them here. Let's carry this here, and let's carry this here. Okay, so these are investors, and this is the founder. Now, what does a founder give in return for investors? So investors provide money to company, and they need something called ROI, okay, return on investment. Now, what do Web3 projects or Web3 companies do? They provide their own tokens. So let's say this company has a token called token C, right? Token C. Now, this token C will be given to these people, as the token value will keep on increasing as the project grows, but it will not be given to them as an instant. Let's say there are 10,000 tokens allocated to A, but they will be allocated over a time of let's say 2 years. So we can directly say that the 10,000 tokens are spread over 24 months, and on 24 months we can have a little division here, and 24. So every month they get 400 tokens, and at the end of the 2 years they get all the 10,000 tokens. This can be exponential also, that they can have their own set of time. They can have their own set of a trickling period basically refers to when the tokens are transferred from one person to another, okay, and how much amount the token transfer is for. So let me just spin up the project today, and what I'm gonna do is I will generally use a ERC20 token. So I'll deploy a token very quick, and I'll do that on Anvil today, and we'll run test scripts to actually find out how the whole vesting period goes. So I'll just be back after writing a simple contract for token and deploying it over Anvil. Okay. Hello, we are back again, and I have written this simple contract. I've spun up an Anvil, so I'll deploy this contract in front of you. So let's go for RPC URL, which will be the RPC URL that is written here. So I just change string, and RPC URL will be this. So HTTP and this private key. That's the basic Anvil setup that we used to do. Okay, now that's that. Now Wedge token is ready. Now this is a simple ERC20 token like yesterday, and we just have written a mint function that mints this much amount of token to this guy basically. So now let's open another contract and vesting. Actually, let's make this token.sol and let's make the other file vest token.sol. Okay, so that's okay. Now let's just copy a few things from here. Let's copy these, and what we need is something called IERC20. What is IERC20? So that is the interface for interacting with any ERC20 token. So let's say I want to interact with USDC, I want to interact in whatever, I will use that AI ERC20 contract. Okay, it is also present in OpenZeppelin. So we'll use import @ OpenZeppelin /contract/token/ ERC20 and /ERC20.sol. I'll use just IERC20.sol. Okay, and now let's write contract vesting token is not, should we go for ownable? Now there is something called ownable, which lets you someone an address own this contract, which we need in this case as we want the user to have control over this contract. So it is just an only owner contract that we used to have, but it is directly implemented in this. So we can have this is ownable console and is ownable, and then we go here and we need to have the constructor for is ownable and ownable message.sender, that's the constructor. Or do we need anything else? The ownable has needs who is the owner, basically that's what we need. Now let's just write which token will we be interacting with. So we will deploy this token, we'll use deploy scripts today, and we will use this address as an interface here. So IERC20 public vesting token. Okay, that's right. And now we want to write that what is the vesting schedule for it, right? So let's write a struct. Basically struct is a data type that we can make for the contract, and we can use it as a data type for various things. Okay, so we will use this as a mapping for from where the addresses are mapped and against what schedule they are mapped. So let's say this founder has its own address and it is mapped against a schedule. This guy has his own address and it is mapped to a schedule. This guy also has an own address and it is also mapped to a schedule. All right, so let's go there. Okay, now what will this vesting schedule have? It will have an amount, so you went to 56 total amount. How much tokens do they need? You went to 56, that will be claimed amount. At how much have they claimed? You went to 56 cliff duration. So cliff duration refers to how much time do they need when they, and like how much time should pass when all of their amount is converted into their claimed amount, right? So this cliff period means an initial cliff that keeps rising. So as you go towards the end, you will get more tokens, and in the starting it's less, as the trust between people is less, so they can dump on someone and whatever. There are a million reasons for this. Now there is a start time and there is an end time, and there is an end time here. Oh, it did not have this. So should we go for a duration that is here? I guess 5 things are enough. And just one more thing, the start time. This is the, now let's make a mapping from address to vesting schedule and vesting schedules. Let's name it public vesting schedules for a lot of people, right? Now the constructor will also need an address of which token are we going to go. So this token.sol will be deployed at any address, which will be whatever gibberish, and that will be the address that will pass to this contracts constructor. So vesting token is equal to interface of token. Okay, now the first function that we need here is called set vesting. Set vesting will be equal to having adding a new address and a vesting schedule for that address, right? So function set vesting schedule. I'm not trying to go with what AI is suggesting, because this is something that is very sensitive and can lead to a lot of problems if not set correctly. So there will be an address, beneficiary, that who is getting the token, how much amount of tokens they are getting, the cliff duration, and the duration and the start. Okay, and now this function will be an only owner function, which we can directly write as it is directly imported from the ownable.sol. As you can see, this ownable.sol has an only owner modifier. So exactly, that's what we can use here. Now, what do we need here? That the schedule should be 0 for that person, and if he has been already set or not. Okay, so require underscore beneficiary. Oh, let's make some errors, custom errors. Vesting schedule already exists, vesting schedule does not exist, error vesting schedule. And we can also have that amount cannot be 0, amount cannot be 0, and then we will have this called amount exceeds total amount. Yeah, exactly. Cliff duration cannot be 0, duration cannot be 0, start time cannot be 0, start time cannot be in the past, cliff duration cannot be. Wow, so AI is very good at suggesting all this errors, and we'll try to use as many as these errors that we can. Duration cannot be less than 0, amount cannot be less than 0, whatever. I have done that. Okay, now so first thing we need here is we need to check if the vesting already exists or not, and if the amount is not set or amount is not 0 when we are calling this function. So require vesting schedule. So vesting schedule already exists. Did we make this error? Yes, we made the error. So let's just go for an if statement here. Let me just do this a little so it's clear for me. If revert with vesting, if revert amount cannot be 0, cliff duration cannot be 0, start time cannot be 0, if, yeah, exactly, start time cannot be in the past, cannot be greater than the duration. These are some errors that I will explain. So the total amount cannot be greater than whatever the amount is set for the person. Okay, so now if cliff duration is less than 0, and thus if duration less than 0, duration cannot be less than 0. Do we have this error? Yeah, we have this error. Okay, I guess this covers the error. Now let's make a vesting schedule for the address is equal to vesting schedule, and total amount. Yeah, we initially all the tokens that are vested to the person will be 0, and eventually we'll go for starting those vesting schedules, and the require will be from token dot transfer. So every token here, so vesting token dot transfer from, so transfer from will call the message dot sender and pass it to the address, which will have an amount. So basically, let me explain how this works. So the founder the founder how do I rotate this? Yeah, I rotate it like this. So the founder actually deposits money worth how much is A needs, right, into the contract first, and the contract slowly trickles it into it. It does not mean that the founder or the owner of this contract has to release them monthly basis. They can invest, put deposit all the money in the contract at once, and those will keep on trickling to the person as the time passes. Okay, so let's go here, and we will say vesting token transfer from, let's go dot transfer from. Now transfer from is also a native transfer from would be message dot sender, because it's an only owner function to address this, and the value will be equal to total amount. Okay, total amount, yeah, exactly. So this is what we have, and then we will emit something which is called or I think I should hold this somewhere. So let's just give it a bool success here. Bool success, I'm not sure if to do this. So bool success is equal to, yeah, and transfer failed. Basically that's what we want to emit. So let's say error uh, cannot set vesting schedule, cannot schedule, and I'll just do this, and then I'm gonna be writing this contract. So require will be failing, and this will be the function that sets the vesting schedules. And now we'll go for the function to claim vesting. Actually, yeah, claim vesting. So we need to transfer the functions and externally call them. So these function will be called by the people who are beneficiaries in the contract. So we will ask for the schedule of the person, and if the token and if the time has passed, and if it is releasable, there will be a releasable flag here. If the schedule allows that the tokens are transferred, then the token will be transferred. Okay, so let's go for this. So vesting schedule storage basically is just a type where we store the schedule. Yeah, this we want. So schedule does not exist. Claimable account, if claimable account, now get claimable account does not exist, so we can make a getter function here, but it's easy for us to, let's just make some requires here. Okay, vesting schedule not exist. Now if block dot timestamp and total amount is, so this is a very smart math here. The schedule dot start time and schedule dot cliff duration. So cliff duration cannot be 0. So what does this signify? That the cliff is not being reached here. So we need to make a new error called error cliff not reached, and we will return with the cliff duration, and we will revert with cliff not reached. That's it. And this will give us, now if it is reached, now what if it is reached? Okay, so we need to get a releasable here, releasable and releasable. Okay, and when we do this, so we will go for elapsed. So elapsed will be a variable which will give us how much time has elapsed. So u into 56 elapsed is equal to block dot timestamp, block dot timestamp minus schedule dot start time. This will give us how much money has passed from the current time from when it has started. So this will give us the releasable will be equal to elapsed into total amount divided by schedule duration. This is a very easy cliff that we have designed here. So what does this mean is, let's say if from 24 months, let's say our cliff is at 50. Okay, if let's say 10 month has passed, into the total amount which is 100 and divided by the duration that is 15. Okay, now if this is 0, then we can pass it, and if it is not, then we just claim it as an amount to claim. Okay, now if releasable is greater than schedule dot total amount, so that is the total amount, we just assign releasable is equal to schedule dot total amount. This will change the releasable and it will give us what amount to release. So UN256 claimable is equal to releasable minus schedule dot claimed amount. That is how much is required for the person to get at this time. And if it is 0, we can revert with nothing to claim. So let's make an error here. Error, nothing to claim. And we'll go for UN256 claimable. Claimable. Yeah, we'll return it. Yeah, we'll return it. So if claimable is equal to 000, then it is nothing to claim. If it is not, then we release those amounts. So schedule dot claim account will say that this amount has been claimed, and then we will transfer those token for the message dot sender. Okay, that is a very simple contract for the person. Now let's get a getter function amount get amount vested. This will give us vested amount for any user will be just a view function. Let's trust AI on this and see if it works well. Okay, now this is a good enough contract for us. Should we write a deploy script now? Let's get back with the deploy script soon. Just give me a second here. All right, guys, sorry, had to take this call. Basically there is a lot that we are planning to do. Okay, let's get back to the deploy script. Let's go for spdx. How do we write this? License identifier MIT. Solidity. Have I used the same version here? Yes, I have used the same version here. std/script.sol. Okay, and that's what we have written here. That works. I mean, that solves it. Sorry. So now we'll import the vesting token and vest token from here. So vest token and vesting token. Yes, these are the right contract names. Now contract vesting script is script and vm.start broadcast and vm.stop broadcast. Okay, vm.stop broadcast, and in between this we will deploy the vest tokens. So address of vest token and vesting token address, vesting token. We can actually deploy this contract and do this, or we can write a test and we can see how this works in real life. So let's just deploy this contract first. That I'll show you the tests, because there is a factor of time which we cannot simulate, but we can do it in the what's the problem here. Okay, let me just reload the window. There is some error here. Yep. So the element of time cannot be simulated directly, but it can be simulated in testing environment. There is something called vm.warp, which we will study about today. And I'm not able to see what's happening here. The script, contract vesting script is a script. Let's see what's happening here. Forge build. Are they building? vm.start broadcast needs an identifier. What's the identifier that vm.start broadcast needs? Oh, yeah. Sorry, guys. Sorry. That's a little mismatch here. That we need to call this all in a run function. Delete. And we have this here. So vest token address. And that's what we are using for. And clg console.log. Token deploy that. Vest token deploy that. Vest token address. Vest token address. Oh, we are calling the same thing twice. That's what AI does, guys. So let's try to build this contract again. And this is successful. Now I'll run the script. So forward script vesting.sol. Let's load the env first. and let's go for purge script slash vesting.sol rpc url $rpc url private key will be equal to $private key. I hope we are familiar with these commands, and that's what we get here. So the contract is deployed at here, Vest token is deployed at here. The Vest token is this, and vesting token is this. Okay, vesting token is this. So Vest token is this, and vesting token is this. Okay, so let's write the test here. So vesting.t.sol, which will be the test script. Let's copy these things here so we do not have to write them again. Import test.sol, now console.sol also, so that we can vesting token and vest token. Now contract vest test, that rhymes, is test, and let's write a setup function for them. So setup, which will have everything here. Now there is an owner, vesting token, vest token. So vesting token is this and vest token is this. So let's go for that, and we'll be going with external here. Vesting token is this, and so this is the this is the vesting contract, and this is the vesting token. All right, that makes sense. Yes, it makes sense. Okay, now let's go for address owner. Okay, we need an owner here, and owner is equal to whatever. Yeah, they start the prank, and yeah, that's fine enough. Is equal to vm.address, and we can actually give a name here to this guy. We can give it, let's say, Hearth. Okay, that's cool. vm.address, sorry, event required. All right, so vm.mock address, there is some function that we can call here. Address, prompt address, random address. There are a lot of ways to generate an address. Let's go for one here. vm.start prank owner, he deploys the token, so he gets them, and then this is here. Now let's see how good can ChatGPT write the tests, and how can we debug those tests. So let's open up a new window here, ChatGPT, and let's give it a temporary chat and write me tests for this contract. Okay, let's give it the contract. We'll deploy and we'll run through every test here, and I'll show you the coverage that I was talking about the last time. We did not get a lot of time. So we have to identify, write them in Foundry. It was using hard hat. For hard hat folks, you can go to the other playlist that is live on the channel. It is managed by Dave, and there is a lot of hard hat development in that. We are focused on this. So yeah, we need a token.approve. So we need to vest token.approve, vest token.approve, vesting token, and let's go here, vest token.approve, address token, you want to visit max. So this has approved here the maximum amount of tokens for this. So I explained this in the first video that you have to approve how much you want to transfer, let's say MTK. So I have 20 MTK, and some contracts ask me for approval of 10 of those, right? So I say yes, and then they can call the transfer from function. So folks, go back to the first video and see if you can find the same thing here. Now this is the test written. Let's go back to our window of ChatGPT and see if we have this here. So let's just copy what the test's names are, right? And then we'll write them on our own. Then there is a cannot set schedule without zero cliff. Okay, these are just cannot functions, so that means that they should fail. The schedule works, so that is right. And claim after, yeah, that is the function that I was calling about. There is something called vm.warp, which we will be using here very soon. Full vesting claimable after duration. This is also a test that we need here. Cannot overclaim, yeah, that also we need. Yep. And we get vested matches claims. Should it match claims or it should not match claims? Let's see that. So these are some reward functions. Whatever. Now let's write these functions down. Let's get to the first function. So there will be vm.startBank and whenever this starts to set vesting, what does set vesting needs? It needs a duration total amount 0, and the duration shall be 0 for this to fail. So total amount, let's write a beneficiary here first. Address beneficiary, so that we don't have to refer to this address, right? Rather we can just call the beneficiary right here easily, and that this way we can do this. Yeah, cool. And the total amount will be 100 on whatever here is 100 ether, right? That's what we can do. Yeah, we can do that. Yeah, with 0 amount it cannot be done, so that's what we need here, right? Now let's test the first function. Okay, let's test if this works right. I'm not sure if it will, but let's go and let's test this function with 0 amount. And let's yeah, there is an expect revert. So what does expect revert does is it did, because you need to set up. What is we just misspelled the setup. Yeah, see if it fails at what we want to fail. So it fails because we do not want it. So if I say cannot be 0 selector, and that means that we cannot set this to 0. What is the problem here? Not find. Man. Oh, no way. No way, man. It is building, bro. It is building. Yeah, it is building. So let's just give this to ChatGPT and it will write all the tests. The tests for us. I guess there is some version mistake here. Let's see if it writes all those tests here. There is a vesting token in set and 001, 100 ether, 100 ether. I think these ether calls should fail as we have an ether here and do not have a ERC20 call. So I don't think these will work completely well. We'll have to fix some of these. We don't need them to be ether, we need them to be ERC20 tokens. So let's just copy this file and let's paste this file here and let's see if the same works. It works actually. Let's see if test schedule works, is passing, right? So SMD, it fails because ERC20 insufficient balance, and 500 ether is not what we need here. We need the amount should be in ERC20 and not ether, right? Because that's what we need, right? So we'll say vesting token dot transfer from, so that will be the decimals here. So vesting tokens and funding the vesting contract. So we'll need to transfer some funds when we are importing this contract. So let's transfer. We have transferred 1 million ether into this. That's not what we need. So 1 million into decimals, which is not the right call. We need a static amount here. So we can say u into 56, u into 56 constant decimals is equal to 18, and we'll do this here and we'll multiply it by decimals. Do we get it right? To decimals, that's right here. I'm not sure about these warnings. This will be some compiler error here. And now let's see if it works. Okay, let's see if it works. Yeah, now it works. Now the earlier test should fail, and it does fail because there is an expect revert here. So if expect revert is true, then the test passes, and if it is not, then it fails, right? So now we need to change everything here from 0 0 0 0 100 into decimals and whatever. Let's copy this test file and let's paste this, and let's run through the tests again. If set schedule works, insufficient balance. Let's see what the problem is. Insufficient balance. Oh, that was not the case here. Test schedule works. Test schedule works. So it is initiated by 500 ether. That's what we don't need here. 500 into decimals is what we need here. Yeah, it fails. So we have, let's think about this for a second. Okay, what does AI has given us? The decimals have to be 1E18 and not 18. So that's what we need here. If it is 1E18, then also it is insufficient balance here. Let's see. Okay, 1E18. Let's add the console logs here. So clc console.log balance ERC20 balance of vesting contracts vest token.balance of. Okay, let's just see if it works. Okay, and let's push the logs here. ERC, it has some balances, but still it fails. Okay, so approval should be 256 max. I think we need to give it some more amount here. It still fails. Let's see. Let's try to debug this. Later in the series we'll be reading this call data and understanding what the function actually does, but for now let's let AI do this. Okay, and we'll give it just the right amount of code to start with so that it can have things here. Okay, but it is actually 10,000 into decimals, right? That's what we have here. So what did we have as an initial supply here? Let's go back and let's see date for, let's go to SRC and let's go to token.sol. We have this, so let's go for this. I think this is the same that we have written here, just I guess 1 0 added here. And let's see what the logs are again. Compiler ran successfully, insufficient balance, and let's reduce these 3 zeros now, and let's see if it is transferring 1 million tokens. Insufficient balance again. Let's read through this call data. There is no other way to solve this now. So initially the balance of vesting contract has been funded. Okay, now the vesting contract dot fund balance is done here. Start prank, and it pranked this guy. Oh, are we pranking the right guy? Are we pranking the right guy? Yes, we are pranking the right guy. Yeah, I think we are. Oh, so equal total should be equal to 500 into decimals. Is that what we are failing at? Nah, we are not failing at that. So let's go here and let's go here. Let's add logs here. Vesting schedule set for beneficiary. Console.log balance. Right. Okay. Let's read the balances here now. Let's open this up. Live debugging is so much fun. Let's read the contracts. So it has this much amount of money, right? And we are trying 500 into decimals. That's not what we need. We need only 5 into decimals. Let's go for that. We are actually allowing more than we need. So let's go here and let's try this one more time. And let's go here and let's go this. And also we need to give it the balance of vesting contract. Yeah, into decimals, but here let us let to 500 into C. That is what I'm failing at. So we should be at 5 into decimals. That's what it is. I don't think that's what it is. We are still at the ERC20, right? So let's think about this. Okay, beneficiary set vesting schedule needs beneficiary total amount. So total amount. So let's call it if here. If no. If vesting dot balance of vesting, let's go here and let's go for vesting. What's the name here? Address. Let's go here and let's see here. Is greater. Sorry. If it is greater than 5 into decimals, so decimals, then we will set this here. Best token, best VV. There is a small v here, not big V. Okay. And CLG log. Yeah, let's go again here. This is what happens when you test it right. So after and before, this is where we are actually failing. I am thinking that the problem is here. So let's let the AI know this is the problem here. Tokens owner ends up with exactly what you would expect, which is right. Let's let AI not mess with us, and we go for this an external function, and let's start the prank with owner. Start prank owner, and yes, now what we will do is we will set beneficiary 100 into decimals and 1 day, 30 days. What is the 1 day thing? The cliff duration is 1 day, and that will be we start, and the should revert equal to Beneficiaries, assert equal, yeah, and this is not we need. We will go for this and we'll destructure every one of those things here. So yes, that's what we get. And let's see this work, if this works or not. I think this should work now. I'm not sure if it might not work. And if it might not work, we'll postpone the test to next video. ERC20 insufficient balance, that's what we are stuck at. Okay, so let's go back here. This is some ERC20 error here, and let's go through this and let's give it everything here. This is how we debug in the era of AI, and we are setting the vesting schedule. Inside the line, this runs as an address.this, but the owner is, oh, transfer from. Okay, yeah, understood. We are transfer from. We need to call the transfer from, brother, not dot transfer, not the message dot center. So transfer from owner address 1 million. Boom, baby. Let's go this way. Insufficient. Setup failed. Let's see if we have the setup here. Don't pre-fund. Keep the funding, the vesting contracts. Skip the transfer from. Problem. We are calling. This line runs, but it's the owner. You never give owner any tokens. You just minted the vesting token to the owner. Transfer all of it into the, then try to transfer again from owner. Oh, okay, understood. Yes, the funding vesting contract yourself. Keep that. Yeah, okay. So what's happening here? Let me explain. So we are minting this. So we should not transfer from initially. Let's keep it at this. Let's transfer only 100 tokens. And now we'll see that it works. Oh, it does not work. Still, it does not work. Okay. Yeah, understood what's happening here. Let's get back to where we were. I have understood this now. And instead of 1 million, let's go for 100 tokens. Okay. Wow, this is so much fun. So I hope this works now. Yes, it works. So let me explain what I was doing wrong, and why I should not trust AI ever again. Sorry, ChatGPT, I know you have been a great help. So this is the owner. So I was minting 1 million token to this guy and then depositing it into the contract. Let's say C. And then I was calling this owner again to transfer some more funds, which is not possible here, right? So that's where we were stuck here. So we can actually not even transfer these funds here, and still this test will work. So create of vesting works. Boom. And now let's write the other test simply. These are very simple tests. Let's go back and boom 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 boom. We'll see all this tests work, and test schedule works. Let's just remove that, and let's then call the forge test /v. So for assertions failing, test can claim after clef, cannot claim after clef, arithmetic under flow or after flow. So basically you can never trust completely on AI. I'm contradicting myself. I said that we can trust AI in certain functions. So let's go for test function. Test can claim full after vesting ends. I'm very specific in writing the test name, which you all should be. So what had we learned today? That we cannot copy paste from the AI directly, and then we go for this and start prime beneficiary balance, and then we go for here and we increase the data from this. Let's see if it works now. We start prank and this claimable amount is not found or not visible. Vesting token dot claimable account amount should be not that. Vesting token does not have any claimable account, ma'am. So how you can go for this? UN256 claimable is equal to vesting token dot claimable. So we go here, vesting token has no claimable here. So the claimable UN256 claimable needs to be released here. So claim vesting. So assert equal claimable is equal to 102 decimals. Get claimable. Let's write a get claimable. Okay, get claimable, and what we need here is an address user. Actually, what do we need? Yeah, exact address user. Okay, and that's what we need here. I'm hoping that this is very good at writing these functions. Vesting token, not this, like this. Vesting token dot claimable account get claimable, and this will be beneficiary address, and let's go here, claim, whatever. Where are we calling claim, brother? Balance before vesting token dot claim. It's not claim vesting, it's called claim vesting. And let's go here, dot schedules 0x claim vesting. Yeah, so we don't need to pass the beneficiary here. And then what is the error? Remember, claimed account not found or not visible. Vesting token dot schedules dot claimed amount. Let's see if this works. Okay, if this works, yeah, this works. We are good at passing the test, and that's all for today. We have written test scripts and deployed the contracts with a lot of debugging in between, and hope to see you tomorrow.